All right, we're going to start 10-2 today, an extension of yesterday when we talked about arithmetic sequences. Now we're going to move on to geometric sequences, okay? Writing both recursive and explicit again, and kind of building off what we've already learned on those two, okay? So first part, the major difference between geometric and arithmetic is going to be what we're doing to create the pattern, okay? So a geometric sequence is a number sequence in which each term after the first term is found by multiplying the previous term by a common ratio. Okay, so we talked about that arithmetic is when we add something each time, whether it's positive or negative, and we do that by subtracting from the back to the front. Now we're going to be multiplying, so we're going to figure out what we're multiplying by. In order to do that, we have to divide from the back to the front. Okay, so first two say, is each sequence an arithmetic or a geometric? Well, in order to do that, we have to figure out what the pattern is and if it has a common difference or it has a common ratio. So we're going to start by subtraction. And the first thing we're going to do is subtract from back to front. So if I take 16/27 minus minus 8/9, I'm going to get negative 8/27. Then if you do the same thing, 8/9 minus 4/3, you're going to get negative 4/9. So these are not the same, no common difference, which means it can't be arithmetic, okay? So not arithmetic, which means it has to be geometric, but let's figure out what the ratio is. So we're going to divide back to front, same thing. So if I take this one and go this way, I'm going to have division. So 16/27 divided by 8/9. And if we type that in, we get 2/3. Okay. And then do the same thing. 8/9 divided by 4/3. And that answer again is 2/3. And again, 4/3 divided by 2. And we do get 2/3 for that one. And then the last one is 2 divided by 3, which does equal 2/3, right? So this would be a common ratio. So it is geometric. Okay? All right, so multiplying each time instead. All right? So same thing on B. We're going to start with the subtraction. So 9 minus 7.5 gives me 1.5, right? And then 7.5 minus 6 also gives me 1.5. 6 minus 4.5 is 1.5, and 4.5 minus 3 is 1.5. So this does have a common difference, which means it is arithmetic. Okay, perfect. So pause the video and try the next two on your own, doing the exact same thing, and then I'll give you the answers, okay? So answer here, same thing. If you subtract, first time you get like 12.7776. And if you subtract here, you get 5.08. So it can't be arithmetic. If we divide 23.4256 divided by 10.648, we get 2.2. And then if you do 10.648 divided by 4.84, you get 2.2 again, and so forth. So this one would be geometric because it has a common ratio. Okay. And then last one, same thing. So if I subtract here, 297 minus 223 gives me 74. Subtract here gives me 74. 74 again, and 74 again. So this is arithmetic, and your common difference would be 74. So next question. How are arithmetic sequences and geometric sequences similar, and how are they different? So similar, they are both a pattern of consecutive numbers, right? So they both create a pattern. all right? And they're different because the arithmetic is going to be with a common difference, right? And it has addition, subtraction, and geometric is a common ratio, which would be multiplication. Okay? All right, so now we're going to get into our formulas, recursive and explicit. And just like it was for arithmetic, recursive is going to be the one that only finds the next term. Okay, so as I told in the other one, this one is, in my opinion, not very helpful. It's only the next term. Okay, so we're starting off, the nth term would be whatever term you want. The common ratio is what you are multiplying by. And then n minus 1 would be the term before it, right? So again, like we talked about the other day, you need two things to write every single formula, which is going to be the first term, right? And whatever your ratio is. Or the other day it was whatever your difference was. So in this sequence up here, 8, 12, 18, 27, 40 and a half, right? We are looking for a sub 1. So that's your a sub 1, which is 8. And then you're looking for your ratio. So to do that, we have to divide. So 40 and a half divided by 27 gives me 40 and a half divided by 27 gives me 1.5. Okay, 27 divided by 18 is 1.5, and so forth. If I tell you that it's a sequence for sure, you probably only have to do that one time. If you're checking to see if it's a sequence, you'll have to do it all the way through, okay? So my common ratio here is 1.5, and then I'm ready to write my recursive formula. So I've got a sub n equals my ratio, which was 1.5, times the previous term, so a sub n minus 1, and then I have to know what I'm starting at. So a sub 1 equals 8. Okay? So same thing for the next one. You try this one and pause and then come back. So again, I told you a sub 1 and r are the two things you need, right? A sub 1 is your first, so 3072, and your ratio you're going to get by dividing. So this has, I'm going to move this guy up here. This would be a 12, right? So 12 divided by 48. 12 over 48 equals 0.25. So my ratio is 0.25, or you could put 1/4 if you wanted to have that, okay? So then plugging them in, I'm going to have whatever term I want, right? Take your ratio, 0.25, times the previous term. And then your starting term is going to be 3072. Okay? Good. So that was recursive. Now, explicit. So again, explicit is going to be that one that'll give you any term that you want, right? So you're going to start with whatever term I'm looking for. You have to begin with the first term, so we know what our starting point is, and then times the ratio to the n minus 1, because we already took care of that first term, so we need one less than the whole group, okay? So again, still the same. I need a sub 1, and I need my common ratio every time. And it's asking me what is the 10th term in the sequence shown in example 2. So example 2 is back up here, right, where we started with this guy. And it was a sub 1 is 8, and my ratio is 1.5. So I'm going to write the same thing. A sub 1 is 8, ratio is 1.5, and we're going to fill in what we know. So a sub n equals a sub 1, which is 8, times my ratio, 1.5, to the n minus 1. Okay? Now, it asks me what's the 10th term. So I'm going to replace n with 10. So a sub 10 equals 8 times 1.5 to the 10 minus 1. So 8 times 1.5 to the 9th power, and that leaves me with a sub 10, or the 10th term, which is 307.546875. Now, we used all the decimal numbers because they were there on our calculator. If it goes off your calculator to the end, then you have to round, okay? So now you try, do the 4th term, or the number 4, which is the 12th term of that same sequence. Pause the video and come back, okay? So hopefully you have a sub 1, which is still 8, and r, which is still 1.5. And now we're going to do a sub 12 equals our ratio times, our first number times our ratio to the 12 minus 1. Okay? So to the 11th, and when you type it in as the 12th term, it's 691, and we're going to round to the 10th, so 0.9. Hopefully you got that same answer as well. Okay? All right, so connecting geometric sequences and exponential functions. The other day when we did these, we talked about how arithmetic sequences go right in line with y equals mx plus b, which is linear. These are identical to exponential functions, which look like this. So if you remember back, an exponential function is f of x equals a times b to the x. Okay? A is your y-intercept, or your starting amount, right? So when we're looking at our explicit formula, and we have a sub 1 times r to the n minus 1, a sub 1 is just like a up here, y-intercept, starting amount, right? So it's the same exact thing. Then b up here is going to be your ratio, what you are multiplying by each time, which is the same thing as this guy, right? Then x up here tells us how many times am I multiplying it, and that's the same thing that this does. How many times am I supposed to take it to the power? All right, so using that to help us over here, it says the number of subscribers to a blog doubles each week. How can the trend in subscribers be modeled? And over here it says in our first week, we had 5 subscribers. Write an exponential function. So f of x equals a, what's my starting amount? Well, it says in the first week we had 5 subscribers, right? So 5 is my starting amount, times b up here for my ratio. Well, how many times is it happening, right? What am I multiplying by? And that's up here where it says it doubles each week, right? Doubles means it's taking it times 2, and how many times will depend on how many weeks. Okay? So if I flip that and I write a geometric sequence down here, I'm going to have a sub n instead of f of x, right? So what term do I want? What's my starting amount? Well, 5 was my first term, times my ratio, which is 2 because it's doubling, and then how many times? Well, n minus 1, the term before it. Okay? So they are directly related. So you try this one. How many subscribers will there be in week 9 if the initial number of subscribers is 10? Okay, pause the video and then come back and check your work. All right, so just like normal, we need a sub 1 and we need r, right? So our first one, right, the initial number of subscribers is 10, so this is 10. And it says, what's the ratio? Well, the ratio is still the same. It's still doubling, okay? So if I use a sub n equals a times b to the x. So a, my initial one is 10, times 2, my ratio, and it's to the n minus 1. And I want to know how many there will be in week 9. So a sub 9 equals 10 times 2 to the 9 minus 1. And if we do that, we end up with A sub 9 equals 2,560 subscribers. Okay. All right, last one down here. And then we're finished up, okay? Apply the recursive and explicit formulas to the word problems. So the number of people attending the annual Town International Food Festival has decreased 20% each year since the first year. How can the attendance for the first 5 years be modeled? And if the trend continues, what will the attendance be in 10 years? And then you have to look over at your picture. That's why we give you one, right? So it says Annual International Food Festival. There's 1,250 people that attended last year. Okay. So again, I need A sub 1 and I need my R. Okay. So for A sub 1, we only know one number for the people who attended, and that was 1,250. So we got to start with that year and then go from there. For the ratio, if it decreases 20% each year, well, that means that out of the 100% of people that actually came the first year, it went down 20% to the next year, which means that 80% of those people showed up for the second year. We can't put 80 in our formula, so it's a decimal because it's 80%. So we got to go 1, 2, and move it back, which equals 0.8. Okay, so my ratio is 0.8 because it's 80% of the people showing up year after year. Okay, so if it's the first 5 years, then we know that it could be modeled with the recursive because we could count to the first 5 years, right? So recursive is our one that isn't helpful as much. So it's A sub n equals, and then we would take our ratio, which is 0.8, times the previous term. So A sub n minus 1. And then we have to tell them where to start from. So A sub 1 equals 1,250. Okay? Then, if the trend continues, what will the attendance be in 10 years? Well, I don't really want to do that for 10 whole years. So let's do an explicit as well. So A sub 1, again, is 1,250. Our common ratio is 0.8. We've got A sub n equals, and then we have our A times B to the X. So A would be our starting point, 1,250 times the ratio to the n minus 1, right? Now, if we want to do this for 10 years, we're going to take 10 and plug it in for n. So A sub 10 equals 1,250 times 0.8 to the 10 minus 1, which means we're plugging it into the 9th power. And if we do that, we end up with A sub 10 is about 167.7. And we're talking about attendance, right, with people. So we need to go up. So A sub 10 years later, only about 168 people would be attending the festival. Okay. All right, last one here. Hopefully you stuck with me. So the formula A sub n equals 1.5 times A to the n minus 1 with an initial value of 40 describes a sequence. Use the explicit formula to determine the 5th term of the sequence. Okay, well, this one is not explicit. This uses the term before, which means it's recursive. So we need to write an explicit to help us out. Always the same 2 pieces of information. A sub 1, right? They tell us is 40. Initial value of 40. That's my starting point. My ratio is what I'm multiplying by, so 1.5. And I'm going to do A times B to the X. That's what I'm thinking about every time I'm doing this. So A is my starting amount, 40, times B, my ratio, to the X, or to the n minus 1. And then you're plugging in 5. So A sub 5 equals 40 times 1.5 to the 5 minus 1. Okay, which means a sub 5 is 202.5. Okay, then just like the other day, we've given you the formulas down here below, kind of shown you what they look like when you plug them in and when you graph them. Okay, if you have any questions, ask your teacher.